Okay, so this is question number 19 of chapter number 2. You can find this on page number 25 of your book. The question says that a three-phase 380 kilovolt line is 200 kilometer long. It is designed to transmit 200 megawatt at 0.9 lagging power factor. Assume that aluminum conductors are used. If aluminum can carry a continuous current of 3 amperes per millimeter square, calculate the weight of conductor material required as well as the total line power loss. Assume density of aluminum as 2700 kilograms per meter cube and its resistivity as 0.029 micro ohm meter. So to solve this question, you will have a look. You will find the current first. The current is power over square root of 3 times the voltage times the power factor. So just put the values that are given to you in the question. 200 megawatt, square root of 3, 380 kilovolt times the power factor, which is 0.9. So you get the current as 337.63 amperes. Now, for the conductor area, the formula is A, which is area, is equal to the current over the current density. The current density is given in the question as well, 3 amperes per millimeter square. But be careful here, this is given in millimeter square. We will just change it into meter square. So to do that, we will just multiply it with 10 to the power 6. And the current, we just calculated it in the previous step, 337.63 amperes. We will just put it here, and this is 3 times 10 to the power 6. Which is the current density. Just put them here and you will find it to be 1.125 times 10 to the power minus 4 meter square. This is the conductor area, the cross-sectional area. Now the total conductor weight, which is asked in the question, how will we find that? The formula for that is area times the length of the conductor, which is also given to you in the question, times the density of the conductor. So the cross-sectional area, we already calculated it in the previous step. Just put it in here with their units, and then time the length, which is 200 kilometers, and then this is the density of aluminum. So you can see there are 2 meters here, and the third meter is here, and then there are these 3 meters at the bottom. They cancel each other. So in a very nice way, the units will confirm that the final answer should be in kilograms, which is the total weight of the conductor, which comes out to be 60,773. So this was the first part of the question, and in the second part of the question it asks you that to find the total line power loss. Well, actually the question number 20, which is after question number 19, is also related to the same question. So I'll just read this question. Question number 20 of the book, which is on the same page of chapter number 2. It says that find the transmission efficiency and the resistive voltage drop of question number 19. So to find these two, the transmission efficiency and the resistive voltage, we have to actually calculate the line power loss, which I calculated over here, which will actually be also the answer of the previous question. So we will calculate the resistance, which will be given with the formula resistivity times the length over the area. Resistivity is already given to you in the question, you can see here, and then times the length of the conductor, also given to you in the question, and then you will find divided by the cross-sectional area, which we already calculated in the previous step. So just calculate this and you will find the resistance of the conductor, the whole conductor, to be 51.56 ohms. So how do you calculate the line loss per phase? This 51.56 ohms, which is for one phase, okay, you will multiply it with the I square. So resistance times the I square, which is the current, also calculated in the previous step. If you can see here, this was the current. You just multiply the R with the I square and you will get the line loss in megawatts for one phase, which is 5.877. For the total line loss, all you have to do is just multiply it with 3 because it's a 3-phase line. So 5.877 megawatt will be multiplied with 3 and you will get the total line loss, which is 17.631 megawatt, which was actually required in question number 19 here to calculate the total line power loss. Now this information will also be used to calculate the transmission efficiency, the line efficiency. So what's the formula for the line efficiency? It's just the power, the transmitted power of the line, and you subtract from it the total power loss and then divide by the transmitted power of the line times 100, of course, and then you will get 91.18%. This will be the line efficiency which is asked in question number 20, the first part of it. The second part actually asks about the resistive voltage drop. So how do we calculate the resistive voltage drop? If you look here, the voltage drop is actually equal to the resistivity times the length times the current density. All three of them are already available to you. The resistivity was given in the question, 0.029 times 10 to the power minus 6, which was micro ohm meter, times the length of the conductor, aluminum conductor, also given to you in the question, times the current density. But of course the current density in meter square, so which is 3 times 10 to the power 6, and you multiply all three of them and you will get the total voltage drop of the transmission line, which is 17,400 volt.